In this video, we want to learn how we can use half-angle formulas to find the exact value. Here you can see a list of half-angle identities that we can use for finding the exact values. For deriving these formulas, you can use double angle identities and easily you can derive these formulas. But here our focus in this video is not on how to derive these formulas. We want to use these formulas for finding exact values of expressions like this. We want to find sine of 22.5 degrees. Because we want to find sine of 22.5 degrees, sine of 22.5 degrees, it should be clear that we have to use this formula. Based on this formula, sine of 22.5 equals plus minus radical, but before we continue, plus or minus, because this has only a single value. It is either positive or negative. Because sine of 22.5 is positive. How we know it is positive? Because 22.5 is in the first quadrant, and in the first quadrant sine, cosine and tangent are positive. So we consider only the positive sign for radical. So sine of 22.5 is a square root of 1 minus cosine of, attention, in this formula, whatever the angle is here, in the formula, in the other side is double of that angle. Here is theta over 2, but here is theta. Theta is double of that. So 22.5 double that angle. If you multiply 2 by 22.5, it would be 45 degrees. So here is 45 degrees all over 2. And from special triangles, we know that cosine of 45 degrees is a square root of 2 over 2. Let me remind you, if here is 45, 1 root 2. Cosine is adjacent over hypotenuse, so cosine of 45 is 1 over radical 2 or radical 2 over 2. Because 1 over radical 2 is radical 2 over 2. If you rationalize this, you can write 1 over radical 2 in form of radical 2 over 2. 1 over radical 2 times by, if we rationalize this, radical 2 over radical 2, this equals radical 2 in numerator, and in denominator radical 2 times radical 2 is 2. So cosine of 45 degrees is radical 2 over 2. And now in this way we can find the value of sine of 22.5. So this equals 1 minus radical 2 over 2 all over 2. Now for simplifying this expression, you can subtract these two, do a common denominator, then divide by 2. But the easier way is to multiply all the numerator by 2, all the denominator by 2, and by multiplying by this number we can get rid of this fraction. So if we multiply the numerator and denominator of this fraction by 2, we have this equals radical 2 times 1 is 2. 2 times radical 2 over 2 is radical 2, because 2 with 2 cancels, and in denominator we have 4. Let me erase this from here. So the way that we have simplified the expression inside the radical is not to do a common denominator. It is a bad way. The easier way is to multiply the numerator and denominator by a number that can help you to get to the fraction. Why we have to work with fractions? Let me erase this radical. This radical should cover all of the fractions, so it's better to be like this. If we simplify this answer, it equals 2 in the denominator, because a square root of 4 is 2. And in the radical, in the square root, we have 2 minus radical 2. So this is our final answer. sine of 22.5 degrees is radical 2 minus radical 2 all over 2. Let me show you another example. Find exact value of cosine of 15 degrees using half angle identity. Because if you remember, we have another method for finding cosine of 15 degrees without half angle formulas. For example, we can write 15 degrees in the form of 45 degrees or minus 30 degrees. Then we can use the difference formula for cosine to find this value, and this value is exactly cosine of 15 degrees. Or the other way is to write 15 is basically 60 degrees minus 45. And again, if you use the difference formula for cosine, if you use cosine of alpha minus beta formula, you can find the value of this, and basically you can find cosine of 15 degrees. But here we want to use half angle identity for finding cosine of 15 degrees. So we want to use basically this formula for finding cosine of 15 degrees. Let me write down the formula here. Cosine of theta over 2 equals plus minus radical 1 plus cosine of double of the angle. If we double theta over 2, it's theta all over 2. This is the formula. Based on this formula, cosine of 15 degrees equals radical. Why we do not consider the negative? Because cosine of 15 degrees is positive. It's in the first quadrant, so it's positive. If this angle was an angle in quadrant 2, because in quadrant 2 cosine is negative, then we consider the negative sign from this formula. Cosine of 15 degrees is radical 1 plus cosine of double of the 15. 15 double 30 all over 2. We know that from special triangles that cosine of 30 degrees is radical 3 over 2 all over 2. Let me remind you, if here is 30 degrees, opposite is 1, adjacent is radical 2, hypotenuse is 2. Cosine is adjacent over hypotenuse, so cosine of 30 is radical 3 divided by 2. Now we have to simplify the expression inside the square root. If we multiply again the numerator and the denominator by 2, by multiplying the numerator and denominator by 2, we have radical. We multiply all of this by 2. 2 times 1 is 2. 2 times radical 3 over 2 is radical 3. And if you multiply 2 by the denominator, it's 4. When you multiply the numerator by any expression, you have to multiply the denominator by same expression. Don't forget this. So this is our final answer. And we can write this in the form of, so cosine of 15 degrees is radical 2 plus radical 3 all over 2. Because the square root of 4 is 2. Now, if you compare this answer with the answer that we can get from the other method using the difference formula, you will see that the answers seems to be different, but actually they are the same. Let me show you what answer we get if we use the difference formula. For finding cosine of 15 degrees, we can write 15 degrees in the form of 45 degrees minus 30 degrees, or 60 minus 45. I'm using 45 and 30 here. Based on the formula that we have for cosine of alpha minus beta, cosine of alpha minus beta is cosine alpha, cosine beta, plus sine alpha, sine beta. This is the formula that we have for cosine of alpha minus beta. Based on this formula, what is cosine of 45 minus 30? It equals cosine 45, cosine 30, plus sine 45, sine 30. Now let's simplify and find these values. Cosine of 45 is radical 2 over 2. or 1 over root 2. So cosine of 45 is radical 2 over 2. Cosine of 30 is radical 3 over 2. Sine of 45 is similar to cosine 45, radical 2 over 2. Sine of 30 degrees is 1/2. If we simplify this equals radical 6 over 4 plus radical 2 over 4. So based on this method, cosine of 15 degrees, don't forget this is 15 degrees, cosine of 15 degrees is radical 6 plus radical 2 over 4. As you can see, it seems that these answers are not the same. This is radical 2 plus radical 3 over 2. This is radical 6 plus radical 2 over 4. Why this happens? Because if you pay attention, these are the same, but they look different. And I will show you why they are equal. To prove that these two answers are equal, we can, one way for doing this, one method, is to raise this to the power of 2 and also raise this to the power of 2. Simplify and you will see that they are equal. This is one method that I want to use here. There are other ways for showing that these two are equal, but they are a little maybe more complicated. I think this is the best way to show that these are equal. But attention, what you have to notice about something. If we raise this to the 2 and we raise this to the 2, if the answers are the same, can we conclude that the original numbers are also the same? Not always, but in this case, yes, because this is positive expression, so we can conclude they are equal. But attention, for example, if you raise 3 to the 2, it is 9. If you raise negative 3 to the 2 is 9. So can you conclude that these are equal? Original numbers are equal? No, because one of them is positive, the other one is negative. But if the original numbers are positive, then yes. If s square of them is equal, so the original numbers are also equal. So here, let's raise these two numbers to the power of 2 and they should be equal. And in this way, we prove that these two expressions, these two answers, these two numbers are the same. Let us start by raising radical 2 plus radical 3 all over 2 to the power of 2. If we raise numerator to the 2, because we have a radical, the radical cancels and we have 2 plus radical 3 all over 4. For the other one, radical 6 plus radical 2 all over 4 to the power of 2. 4 to the 2 is 16. For raising this to the 2, you can write it, you can do it this way, radical 6 plus radical 2 times radical 6 plus radical 2. Or you can use the identity for this. But if you don't know the identity, you can do it in this way, which of course takes more time. So it's better to learn these elementary identities. Radical 6 times radical 6 is 6. Radical 6 times radical 2 is radical 12. Radical 2 times radical 6 is another radical 12. So we have 2 radical 12. Radical 2 times radical 2 is 2. So in numerator we have 8. 6 plus 2 is 8. Plus 2 radical 12 all over 16. Attention, 12 is 4 times 3. S square root of 4 is 2. So s square root of 12 is 2 radical 3. So here let me erase radical 12 here and substitute 2 radical 12 with 4 radical 3, because radical 12 is 2 radical 3 times by a 2 would be 4 radical 3. So we have 4 radical 3 over 16. Now from these two, if we factor a 4, then we have 4 plus radical 3, not 4, 2 plus radical 3. And if we simplify 4 with 16, we have 2 plus radical 3 over 4. If you compare this with this, you can see that they are equal. So this shows that these two answers are equal to each other. Find the exact value of tangent of 9 pi over 8. 9 pi over 8, if you pay attention, is in the third quadrant. Because 9 pi over 8 can be written as 8 pi over 8 plus pi over 8. It's pi plus pi over 8. And so, it's an angle in the third quadrant. And its reference angle is pi over 8. Because pi is this angle, and the pi over 8 is the reference angle. So, instead of finding the tangent of 9 pi over 8, we can find tangent of pi over 8. And because in the third quadrant, the tangent is positive, so the tangent of 9 pi over 8 is equal to tangent of pi over 8. If it was negative, you have to put a negative here. But because in the third quadrant, similar to the first quadrant, the tangent is positive, so tangent of 9 pi over 8 is equal to tangent of the reference angle, which is pi over 8. Remember, all students take calculus. In the third quadrant, tangent is positive. So, now we have to find tangent of pi over 8. But which formula between these three formulas that here we have, it's better to be used here. It's completely up to you. You can use any of these and the answers would be the same at the end. Here I want to use this relation for tangent of theta over 2. Tangent of theta over 2 is sine theta over 1 plus cosine theta. You can try with the other formulas and you will see that the answer at the end would be the same. Based on that formula, tangent of theta over 2 is sine theta over 1 plus cosine theta. So tangent of pi over 8 equals sine of double of the angle. Here is theta over 2, here is theta. So double this angle. Double of pi over 8 is pi over 4. Sine of pi over 4 all over 1 plus cosine of pi over 4. We know that sine of pi over 4 is 1 over radical 2 or radical 2 over 2. Cosine of pi over 4 is radical 2 over 2. For simplifying this again, we multiply the numerator and denominator by 2 because we want to eliminate the denominators. This equals radical 2 all over multiply 2 in the bracket 2 times this would be radical 2 because denominator with numerator cancels. This can be your final answer, but if you would like, you can rationalize this answer. If you want to rationalize your answer, simply you can multiply the numerator and denominator by the conjugate of the denominator, 2 minus radical 2. In this way, you can rationalize. So we have in numerator 2 times radical 2 minus radical 2 times radical 2 is 2 all over, if we multiply this by this, 2 plus radical 2 times 2 minus radical 2 would be 2 to the 2 minus radical 2 to the 2. So this equals 2 radical 2 minus 2 all over 4 minus 2 is 2. If you factor a 2 from numerator and cancel that 2 from denominator, the final answer would be radical 2 minus 1. So tangent of pi over 8, 9 pi over 8 is radical 2 minus 1. And we used half angle identity for finding this exact value. I hope by watching this video, now you are more familiar with half angle identities and how we can use them to find exact values. If you like this video, please subscribe in my channel and see you in the next videos.